Welcome to this video on exponents in scientific notation. Students will extend the definition of exponents to include all integers and in the process codify the properties of exponents. Here are the essential vocabulary words that will be introduced in the unit. Exponent in scientific notation. Students will learn the rules of multiplying and dividing expressions with exponents. Exponents are a way of keeping track of how many times a number has been repeatedly multiplied. For example, instead of writing 8 times 8 times 8 times 8 times 8 times 8 times 8, we can write 8 to the 7th power instead. The number repeatedly multiplied is called the base, which is this in this example 8. The 7 here is called the exponent. Using the understanding of repeated multiplication, we'll figure out several rules for exponents. Suppose we want to understand the expression 10 to the third power times 10 to the fourth power. Rewriting this to show all the factors, we get 10 times 10 times 10 times 10 times 10 times 10 times 10. Since this is really 7 tens multiplied together, we can write 10 to the third power times 10 to the fourth power equals 10 to the seventh power. By counting the repeated factors that are 10, we've added the exponents together. There are 3 of them and then 4 more. This leads us to the understanding of a more general rule about exponents. When multiplying powers of the same base, we add the exponents together. Using similar reasoning, we can figure out that when working with powers of powers, we multiply exponents together. Students will use powers of 10 to work with very large or very small numbers. For example, the United States Mint has made over 500 billion pennies. In order to understand this number, we have to count all of the zeros. Since there are 11 of them, this means there are 500 billion pennies. Using powers of 10, we can write this as 5 times 10 to the 11th power. The advantage to this way of writing the number is that we can see right away how many zeros there are. There are 11 of them, and more effectively compare numbers when they are both written in this form. The same is true for very small numbers. If we write this number using the power of 10, it becomes 1.99 times 10 to the negative third power. Not only do powers of 10 make it easy to write this number, but they also help us avoid errors, since it would be very easy to add or take away a zero when writing out the decimal without realizing it. Writing numbers in this way is called scientific notation. We can use the exponent rules learned earlier to estimate and solve problems with scientific notation.